Imagine looking up at the night sky tonight and seeing two moons. One is our familiar glowing white satellite. The other is a pitch-black obsidian nightmare, a massive shadow world that reflects almost no sunlight, drifting into high Earth orbit. You wouldn't see it coming until the stars behind it vanished, but you would feel it immediately. Within days to weeks, catastrophic tidal forces would begin reshaping coastlines, earthquakes would intensify along major fault lines, and the 24-hour rhythm of life on Earth would be changed forever. This isn't science fiction. It is a look at the physics of what might happen if a low-albedo rogue celestial body were captured by Earth's gravity. Here is one possible scenario if Earth gained a dark twin moon. How could a second moon exist without us seeing it? In space, not every world is bright. While our moon reflects about 12% of the sunlight that hits it, dark asteroids and planetary fragments rich in carbon compounds can reflect as little as 3%. Against the darkness of space, they are incredibly difficult to spot. Now imagine a rogue dark moon, half the mass of our current moon, drifting through the solar system before becoming trapped by Earth's gravity. As it settles into an orbit halfway between Earth and our original moon, its presence isn't revealed by light, it's revealed by gravity. Tidal force increases dramatically as distance decreases, following an inverse cube relationship. Because this dark twin orbits much closer to Earth than our moon, its gravitational pull could produce tidal effects far stronger than those we've experienced for millions of years. And the oceans are about to react. Under a single moon, ocean tides rise and fall smoothly. But with two moons pulling from different directions, the oceans would be thrown into chaos. When the original moon and the dark twin align on the same side of Earth, their combined gravitational pull creates an extreme tidal event, a supersyzygy. Instead of ordinary high tides, coastal regions could experience unprecedented flooding, with some areas potentially seeing walls of water hundreds of feet high, depending on the dark twin's exact orbit and distance. Massive surges could race dozens of miles inland, overwhelming many of the world's coastal cities beneath unimaginable volumes of seawater. And the water is only half the problem. Gravity doesn't just pull on oceans, it also flexes solid rock. The dark twin's gravitational influence would increase tidal stresses within Earth's crust, generating additional internal friction through a process known as tidal heating. Fault systems around the world could experience far more frequent and powerful earthquakes. Volcanic activity, especially around the Pacific Ring of Fire, could intensify dramatically, sending enormous quantities of ash into the atmosphere and potentially triggering years of global cooling. Above the crust, the atmosphere itself begins to respond. The twin moons would create unusually large atmospheric tides, disrupting global wind patterns and fueling storms far beyond anything in recorded history. Human technology would also face an unprecedented challenge. Thousands of GPS, communication, weather, and military satellites could have their orbits significantly altered by the changing gravitational environment. Some might collide with one another, while others could eventually fall back into Earth's atmosphere, disrupting global communications and navigation. Meanwhile, nature is thrown into chaos. Millions of species depend on the lunar cycle for migration, hunting, spawning, and reproduction. A second moon with a completely different orbital rhythm would disrupt ecosystems worldwide. Sea turtles, coral reefs, nocturnal predators, migrating birds, and countless marine species could struggle to adapt, causing cascading ecological collapse. How does this end? In celestial mechanics, a system containing Earth and two closely orbiting moons could become dynamically unstable over long timescales, depending on the exact masses and orbits involved. Several outcomes are possible, but two of the most dramatic are these. Outcome 1. The Great Collision. Over thousands or even millions of years, gravitational interactions could gradually alter the moon's orbits. If they eventually collided, the impact would release an unimaginable amount of energy, sending vast amounts of debris throughout the Earth-Moon system and potentially causing catastrophic impacts across our planet. Outcome 2. The Saturn scenario. If the dark twin drifted inside Earth's Roche limit, Earth's gravity could tear it apart before it reached the surface. The shattered remains would spread into orbit, forming a spectacular ring of dark debris encircling our planet.